And I'm going to share my, welcome to WeatherWatch. I'm going to share my screen at this point because I've got stuff ready to go. And it should look a little funny in a second to you, but then by the miracle of Pete, it will come back to something more normal, like right now. Hopefully, is that correct?
Yep, looks good, John. I'll monitor the
Okay.
chat. If anybody has any comments or questions, go ahead. If that little purple thing in the lower right-hand corner, if you click on that, there's a chat down in there, and I'll keep an eye on that and pass things along because John doesn't necessarily see that, or the presenter doesn't necessarily see that when they're presenting. So I'll break in and pass stuff along.
All right. Thanks, Pete. Well, I want to start the discussion today over about the current weather and the recent past weather by looking at elements of our storm from this middle of this week. I think it came in on Wednesday, and then it was a really windy Thursday in its wake. So we had, moderate rain for a good part of the day on Wednesday, a pretty soaking rain. A couple of times it was heavy, and then in other locations not too far to our east, it rained all day long. Like I think Milwaukee and the entire Lake Michigan coastline of the state of Wisconsin had pretty heavy rain for a good part of the day. So take a look at several elements of that. On the national scale, that storm brought some pretty intense severe weather, although only a few tornadoes, luckily, across the south central plains, as you can see, across Oklahoma, parts of Arkansas, Louisiana, and northeast Texas and southern Missouri. A lot of wind reports, 300 or more wind reports. A couple of them were high wind reports, which are over 65 knots. Those are the black squares. I guess there's one near Monette. There's one to the northeast of Oklahoma City, and there's one sort of in the Dallas area at least, and there's one other one I can't seem to find by eye on the map. But quite a number of interesting weather events tied to the development, fairly rapid development of this cyclone. Oh, the other high wind report was over here on the North Dakota-Montana border, so I don't know what happened there, but it's unrelated probably to this event down in the central plains. So I wanted to show you a couple of different things. Let's see. First, how about precipitation over our state? Let's see. This is current minus 1 day, minus 2 days. So this is now for ending the morning of the 28th. So this is as the storm was brewing to our south and west. We'd had a little bit of precipitation on that Tuesday, but not anything significant. Then on Wednesday, as you can see, this is from the Midwest Regional Climate Center. They have a lot of nice products there. You can see some pretty heavy rain amounts. Where it gets orange, you're talking 2.5 to 3 inches of rain in some of the south central counties of Illinois, just across the river from St. Louis. And then the same is true again in the far western counties of Michigan during the day on the 29th. So it's a 24-hour rainfall. And in Dane County was split in half. The far southeast part of the state had upwards of a half an inch, and then the northwest part of the state, the county, had maybe a tenth of an inch on that day. But then during the day on the 29th, you had, as you can see, along the coast of Lake Michigan in our state, some really heavy rainfall amounts. Milwaukee County had an inch to inch and a half to 2 inches, the same in Racine. And then further up along to Washington Island and the Door County Peninsula, the same thing. Dane County was split again, this time east to west, very heavy rains approaching an inch or more in some places on the far eastern part of the county, and then in the far western part, with the exception of Casa de Tripoli, which probably had 5 inches of rain. There was a tenth of an inch on the far western part of Dane County. So we had, overall, we had close to half an inch of rain in the vicinity, Madison metro area, Wednesday night into Thursday, and then very windy on Thursday. So an interesting storm, and you get a sense from this map right here that it was broken into two pieces at the late stages. And Pete had a nice radar reflectivity, which I'll have him show in just a minute. But the far southeastern portion of this domain over parts of Kentucky and southern Illinois and Indiana, that's on the southeastern side of the storm. And then all the heavy rain that was mostly spilled over the lake, as it appears, from the amounts on land astride the lake, that is probably in the sort of occluded quadrant of this weather system, at least its northwest quadrant at this time. So we're going to take a look at a broader picture of what this storm looked like at a couple of different times. Unfortunately, it'll be somewhat primitive analyses, but then at upper levels, since we have the Super Pete movies, we get a really nice view of what was going on at upper levels to develop this weather system. But before we do that, Pete, could you take the screen? I'll relinquish, and then could you take it and then show that radar reflectivity that you had? Because there were other parts of the country that had some really interesting things going on in association with this storm. And then we'll come back and look at some of the upper level charts.
Hey, John. Hey, John, as
Yeah.
Pete's bringing that up, could we return back to that image once Pete's done with that radar loop? I'm going to have a question to ask, just curiosity.
Oh, yeah. Yep.
Okay, thanks.
So here's Pete, thanks for saving this during the week. I showed a couple of aspects of this during class this week, online, of course. And so we have our weather system is spinning around in the eastern or central Great Lakes states. And early on in this evolution, this is 24 hours long, Pete, is that right?
This is like 3 days long. It starts at 0 Z
okay.
on the 28th and goes through now, basically, or a half an hour ago when I made it.
Oh, great. Okay. So we're looking at the whole progression of this storm across the
It'll
country.
start over now.
And it developed in situ. This was a homeborn storm, so we'll see that. So a little bit of precipitation in the northern plains, and then seemingly unrelated, heavy convection. Oh, that thing's got to get out of the way, that movie bar. Heavy convection flooding the far southeastern states. Look at that squall line. And I can tell you from the satellite movies, that front edge, the leading edge convective line, never really dissipated. It just got out of radar range. That was an impressive leading edge of severe weather. Imagine being out on a boat anywhere in the Gulf of Mexico on the 28th of April, pretty nice day. And then by the time late in the day or early on the 29th, you're out there, not at anchor, just hoping to make it through. Unbelievable. Yeah, Dave Mikolicek said a lot of lightning associated with that thing too. And it was, Alex, you're right. It's exactly what it looked like, midsummer derecho. And it starts out as this kind of a squall line, and then look at that thing racing southeastward across the western Gulf of Mexico. Meanwhile, the storm's getting kind of wrapped up and stalling, more or less sitting still. We'll see that in the surface analyses in a minute, right over southwestern Michigan. And that kept us, at least the far eastern part of the state, in a prolonged period of moderate rain. We escaped a little bit earlier than that here in Dane County, so we didn't get quite that same amount of precipitation. We've got some on the doorstep today, as you can see. But then you'll see it kind of raining along the middle Atlantic in the late stages. This is the early stages of this cyclone. So there's convective precipitation band number 1. We got another one later in the day. And there's the main event. This stuff built back to the west because the cyclone occluded and sat still. And then here's the main cold frontal precipitation band reinvigorated as the upper wave develops, which you'll see in just a minute. And that goes roaring to the northeast across first the middle Atlantic states with a soak, and then a pretty soaking rain last night into this morning over New England. So a very interesting weather system. And then the next thing's coming online here to the west, draped across the state of Minnesota. We'll see something from that perhaps in parts of our state today, but maybe not in Dane County. So let's, if I could have the control back, Pete, we could spend the whole discussion on this event, but I don't think I want to do that. So I'll go back and.
John, if you could go back to that image for just a second, if it's still up.
Yeah, I kept it up. So here
Thanks.
Here we are. This one here, the precipitation image. Yeah.
Right. So this is just a broad question about, you see that precipitation extends from the northern part of Michigan all the way across Lake Michigan down south of Chicago.
Yeah.
And so the question would be, if someone wanted to estimate the rainfall over Lake Michigan, do we have the tools to do that? Obviously, we don't. If there's a ship that's stationary over Lake Michigan, that would be useful. And you have radar. I imagine you could use the radar to estimate some of the precipitation amounts. I'm wondering if you had buoys at the surface, or buoys that are moored over Lake Michigan. Could someone do a calculation, or do people do this, or using satellite data to calculate the change in surface temperature over the lake, in the lake temperature, and use that to infer something about precipitation amount?
Oh, that's interesting. Yeah, because you would be able to get a really clear view after the thing goes by of this lake surface, and you'd get a nice radiance picture of that. Before and after would tell you how much cooler it is. And yeah, I guess the idea would be that a freshwater influx of rain should cool the surface by a certain amount, prescribed amount. I don't know. That's a really good question.
Right. I mean, you'd obviously need to know the temperature of the rainfall when it hits the surface and some other things. But I wonder if it's something that's measurable. If you wanted to estimate, get a precip estimate across Lake Michigan, because there's that bald spot on the map that we're looking at. But if someone really wanted to know what did that band look like over the lake, could you somehow infer it or get a quantitative measure of the rainfall?
Yeah, it sounds like the logical pieces are in place. I think there'd be some details to work out. But I wonder if that isn't something that can be done. That's a really good question.
Yeah, Ketzel sent a link. There are buoys there, but I'm wondering, is there do people use that data, or has anyone ever done that to estimate the temperature of the lake?
Yeah,
I don't
know.
know. And then, so like not a lot of buoys collect directly precip information. And then, yeah, like Scott said, this is a really kind of awkward time because a lot of buoys aren't deployed till mid-May to like early June either.
Okay. And I guess a question would be satellite data. Could we use satellite data to infer the surface skin temperature, and based on that and maybe some other parameters come up with an estimate of precipitation amount?
Yeah, it seems like you could. I mean, you also have wind driving across the lake. In this
Right.
particular event, you'd have to have a decent estimate of that, and then what mixing that does to bring what contribution that makes to the change in surface temperature of the water, especially at this time of year, and all sorts of other things. But it seems like a problem that would be kind of fun to try and work on.
Right,
Because
but I think you just actually, Scott mentioned, obviously you can't do it when it's cloudy, but if you had, once the weather system goes by and it clears up, obviously you already have time rates of change of things that have occurred. But the other element is, as you said, John, if you know the winds blowing across the water, you're going to get then upwelling or downwelling depending on the circumstances, and so that might also complicate that estimate. But maybe if you have a good lake model and you had good winds, you could estimate what that is and back out something. So anyway, just an interesting question.
Yeah, you'd have to have a good number of constraints, but it's not impossible that you could have those constraints, at least in a reasonable fashion. Yeah, that's interesting.
Okay, thanks.
Yeah, you bet. Okay, now I'll get rid of this. I'll just down it like that, and let's go and take a look at some of the upper level charts that go along with this. So this is the Super Pete movie. This would begin on Monday night, 0Z 28th of April at 500 millibars. I'm going to move this up so we can see it a little bit better. And it looks like a broad zonal flow with a slight southward component across the entire continent, which means in the immediate lee, there's going to be lee side troughing. And we'll see that when we go to the surface maps. This storm takes on a couple of different pieces as it evolves. And partly that's because you've got stuff going on in the immediate lee. So let's go forward here every 12 hours. So you notice right away, I'll go back to the prior time, this is a fairly flat wave across Washington State where I have the cursor right now. Not a lot of strong temperature contrast, or maybe, I guess it's a little stronger here than anywhere else, but not really strong temperature advection. And then there's an upstream ridge with a cyclone developing out over the Pacific Ocean. I think this development, probably enhanced by the approach of this wave, builds this ridge and induces a more northerly flow, northwesterly flow on the western side of this flat trough. So watch this. At the very next time, you suddenly have this really quite impressive jetlet in northwesterly flow with decent baroclinicity and cold advection at its end in the cyclonic shear. And that's going to help to develop this wave that at the time, 12Z on the 28th, was over southeastern Montana. At the next time, it digs substantially across to the Kansas-Nebraska border. We've got wind speed increases of 15 or so knots in 12 hours in the jet core, it looks like. Temperature advection patterns getting stronger. There's actually a new closed off contour of minus 25 degrees C. So there's air rising and cooling on that backside, probably sinking on the warm side. So the upper front's getting intensified. And this is becoming a pretty intense disturbance. These storm reports go from 12Z on the 28th to 12Z on the 29th. So at this point, we're at 0Z on the 29th. We're halfway there, and the storm reports are sort of in this location, a little bit downstream and a little bit south of the downstream region of that upper trough. But at the next time, watch the development here. From 0 to 12, you suddenly have this really robust upper troughiness, 95 knot wind at Oklahoma City. That's the strongest wind in that jet core. And if I just remind you what was there before at 500 millibars, maybe 60 knots. So we've had a dramatic increase in the 500 millibar wind speed during the development of this upper trough. And the baroclinicity is quite intense too. Look at this. It's minus 14. I think that's minus 14 at Oklahoma City, minus 24 at Monette, minus 24 at Kansas City, and probably minus 13, I think, at Goodland, Kansas. So that's a really strong horizontal temperature contrast coincident with a wind speed intensification. That's an upper front developing on the western side and now rounding the base of this carved out upper trough. And one of the things that's interesting, I wish we had a simulation of this because we got 12 hours in between these two times. But as you imagine this jetlet getting stronger, there's an exit region circulation whenever the jet's on the western side of a developing upper trough. And the jet maxima runs here from southeastern Montana to northwestern Kansas. So the left jet exit region is over central Nebraska. That's the air that's rising and cooling. It's also lowering the geopotential heights in that region hydrostatically because it's getting colder. And the consequence is you get a really nice deepening of the upper trough. By this time, we've had our severe weather already pretty much done over this region of the Oklahoma-Arkansas border. But you can imagine in those 12 hours from 0 to 12Z on the 29th, there was a tremendous intensification of an upper jet, upper troughiness, lots of forcing for ascent, and you're not very far from the Gulf of Mexico. So there's a lot of warm, moist air to get involved. And this is getting us on Wednesday morning when we're really starting to see our storm ramp up, and we're in a perfect position for that over the Chicagoland area downstream of this upper trough. And then the trough gets elongated as the upper front portion of it continues to move southward along to the Gulf Coast. And we have a fairly elongated upper trough by the end of the process. And look at how slowly it moves out, sitting over the eastern and central Great Lakes. And here we are this morning. The trough now takes on a little bit more of a cutoff shape. In fact, there's a little more inflection in the geostrophic flow here than is analyzed in the geopotential height lines, beginning to look a little bit like a treble cleft structure aloft, and heavy rains and persistent rains on the eastern side of that. So a really interesting development, not something that would change one's understanding of the way weather systems work, but a really nice example of how fast some of these developments can be in the middle and upper troposphere. We tend to focus our attention on developments near the surface, but the developments aloft can be equally dramatic and certainly equally influential. And here's the 300 millibar sequence. I guess I'll start at the same time. This is 12Z on April 28th. I guess I started on 0Z, where we have, again, a pretty zonal flow at 300 millibars across the higher western mountain range. And then the ridginess is a little more obvious upstream of this inflection where the flow starts to go further from to the north and northwest. So the waviness out over the Pacific spawns this northwesterly flow within which the jet intensifies. And look at here at 0Z on the 29th, the jet is intense on the western side of the upper trough. That all digs upper troughs. Here's the left exit region. Air is rising here, cooling as a consequence, and the trough's getting deeper. And then we see this is the just past severe weather period over the Oklahoma-Arkansas border. Very sharp upper trough, extreme wind speed, 130 knot wind on the western side. And then the jet maxima moves to the east side, and that's related in some ways to the convection on the eastern side that we see today that's plaguing parts of southern New England. So a nice example of what's happening there. We've got some upstream conditions here that we'll start to talk about in the current weather discussion that will have implications for the weather over us throughout much of the coming week. It doesn't look like a very nice week that's coming up. Okay, so let's go back to the current weather. And here's the 6-hour satellite loop over the U.S. and adjacent waters. So here's the current manifestation of that upper trough and weather system that's related to it. And you remember the upper trough axis is just about right along the mid-Atlantic coast, and so downstream of it, beautiful example of where the air rises in relation to the upper trough, and also where it sinks. We have a beautiful morning here this morning. High clouds are moving in, as we can see during the day, but it was a beautiful morning today and a beautiful night last night. We were in the right position for that. Big cloud mass goes all the way up to the southwest coast of Greenland with this weather system. So this is a highly amplified flow. I don't think unusually amplified, but highly amplified. And people on the southwest coast of Greenland are screaming, Mayday, Mayday. They weren't just looking at the calendar, they're worrying about the clouds. That's a little weather humor at the end of the term. So here's our next weather system of interest. And you can see it starts out as sort of in the beginning of this movie, just thin clouds, but you can see that convective line beginning to show up here from draped across Minnesota and now across the river into our own state. So we'll see some of that deterioration as the day wears on, it looks like to me. I'm not sure what's doing this, so I don't have a great sense of how well it will remain put together, but something interesting is happening over the states to our west. Okay, then let's see, what did I have next? The visible satellite image is interesting over the same period of time, and for reasons that are, not worthy of great attention here, but you can see this cloud mass is quite extensive. It's thicker off the east coast than it is thinner high clouds over the in the lee of the eastern lakes. And then there's a really nice low-level stratus that is right along the whole west coast of the Baja Peninsula, and then a big clear spot. The edge here must be really sharp. Some of the islands might have some of those cool von Karman vortices down along the coast, although I didn't investigate that. And you can always see ship tracks when you get this low stratus. Some of the striations here are undoubtedly ship tracks. And then there's a weather system that's kind of nicely put together in the eastern part of the Pacific Basin, and it's kind of making its cloudiness felt in the Pacific Northwest as the day wears on. Not exactly at this moment, but it will be soon. And then here's the radar summary across the continental U.S. There's the rain departing New England finally. It's been a rainy overnight, and then some lingering showers. These might be those sort of Ekman showers, Michael, that you get, just convergence in the boundary layer that give you a little bit of extra precipitation, although I'm puzzled that there's some reasonably high reflectivities here in and around Albany, so I'm not sure it's all that, but there's something interesting going on there. And then this whole, go ahead.
I was going to say that depending on what the lapse rate is, I imagine it's pretty stable there behind the front or under the upper trough, but if it's unstable and you get any convergence in the boundary layer and it can lift it up to its level of free convection, you might be able to spawn some convective type shower.
Yeah, and I think that's a common occurrence in the Puget Sound in post-frontal situations. The so-called Puget Sound convergence zone sets up usually synoptically at exactly the right time when the stability is low. So you get these kind of blossoming thunder showers that can drop, pea-sized hail, even though they're only 15,000 feet deep, because the vertical motions can be intense. So it might be something similar for different reasons going on there today. This reflectivity feature over Minnesota starts out looking ragged and poorly put together, but boy, by the time we get to almost the current time, 12:30, that's a decent line. So Minneapolis, just to the northeast of Minneapolis, a pretty decent convective line, and it's moving across the river into the state. What the fate of the southern tip of this will be will hold the cards for our weather late this afternoon. So in the next 3 or 4 hours, we may see a shower out of that. And then you can see just a little bit of the precipitation coming onshore. We saw that oblique view of the West Coast visible satellite image. That's the leading edge of that next system there. And I think before I show you that image, I'm going to just go to the surface map, take a look at some of the observations.
Share a couple of the comments that we've had in here. Kaylin mentioned when you were talking about the upper air maps that it looks a lot like a midwinter pattern with a negative NAO pattern. Alex mentions that the Mount Holly radar has a really strange reflectivity pattern with a lot of deformation and stuff going on. And Laura says that it's been raining today in Minneapolis so far.
Oh, yeah. I imagine so. And probably getting worse the further away you move from the city to the north and west. I think that's probably more convective. Yeah, so those are all interesting comments. Kaylin's comment about the negative NAO, well, that's the time when you have extraordinary waviness, at least in the North Atlantic. And it appears that it's not relegated to the North Atlantic. You get a wavy flow in adjacent continents too, and North America is the one upstream. So that's interesting. I don't know much about that, but I know a little bit. So here's our surface map for this morning. It's actually an hour and a half or so old because I had to get it earlier. And here in New England, along the coast anyway, in southern New England, it's just miserable. 50 over 51, just a cold, clammy day. But if you're Portland's moderate rain, 50 over 48, it's even worse there. Most of the state of Maine has light rain. Some other locations in New England and in southern Quebec also with some light rain. And this is kind of near the end of the story for that. Nice day in the Carolinas, although clearing up. It's nice, though, when you're in Raleigh, it's 59 over 44. You can't argue with that because soon enough, it's going to be 79 over 78 every day. So who needs that? And then here you are in the middle part of the country. We're 56 over 33. Nice dry air, bone dry air. I mean, we had perfect conditions for it last night. Light winds, perfectly clear skies, great radiational cooling. We got down to the high 30s here in the southern part of the state, overnight lows. And then the sun came in this morning and brought them right back. Yep.
Hey, John, I was going to say that, as you note, the dew point depression being so large, was it 23 degrees Fahrenheit. Even though we have that precip approaching from the west, and even though Minneapolis, there was a little bit of rain in Minneapolis, it's so dry, I think most of that precipitation is going to be evaporating before it reaches the ground.
Yeah, very good point. I even made that to my class today. That's exactly right. Look at it. It's light rain and this station in western Minnesota, 53 over 40. They have a 13-degree dew point depression with rain falling into that. So that's probably right underneath one of these convective elements. Lots more rain evaporating than falling to the ground, as you
And
point
look how
out.
much colder it is. It's 10 degrees colder than some of the surrounding stations.
Yeah, very interesting. Yeah, it's warmer to the north than it is where it's raining, and then warmer to the south. So that's a temperature depression because it's raining into a dry column. Excellent point. So we're going to have a difficult time getting rain to come to the ground here. It'll be cloudy for sure, and sky might even have some interesting texture to it. But I doubt that we'll see anything make it to the ground under these conditions. That's really interesting because it's 70 degrees across the Dakotas and western Montana, and then along the river in Michael's hometown of Omaha, pretty warm. Or Lincoln. Sorry, Michael. Sorry. And then we're at 70 down in Little Rock. We're 72 at Oklahoma City, over 52. That's a nice day for Oklahoma City, too. And then uniformly dry until you get right along the immediate coast in Texas in terms of dew points. You're in the low to mid 50s and then mid 40s further west. So that's a nice day down there, too. And then the Pacific Northwest, no stations on this map with the density we have here are showing precipitation. But look at this. Quileute, 44 over 44 with a flow right off the continent. That's miserable. I mean, that's why, I don't want to say it. No, that Kurt Cobain grew up in this area. I think this kind of weather has something to do with his whole disposition. It's just miserable there. I would never want to live there. What did they call the place up on the coast of Oregon at the Columbia, Lewis and Clark? Point Despondency or something like that. What was it called?
No, I'm not sure I got the right name, so I don't want to.
Cape Disappointment. That's what it was called because they were so disappointed that this was the end of their journey. So awful. Okay, that's enough of that. So let's go to the West Coast satellite movie, and I've got a couple of things left, and that's it. This is very interesting. We got 3 different disturbances. One here at the western edge of the Aleutian chain, one here southwest of Kodiak Island, and one off the coast of British Columbia. This one here, appropriate for the end of the term, looks like a question mark. So we're always questioning. We're always wondering about things. And here's 3 really nice storms. And you can see cold air on the northern side of this streaky cloud features to the south and not so many open cellular convective clouds over here. So this is definitely an upper tropospheric jet feature, cold air to the north, warm to the south. We'll take a look at that in just a minute. And here's the cloudiness. It's associated with this storm off the British Columbia coast. That's just barely beginning to nudge its way onshore in Oregon and Washington. Yeah.
I was going to ask, this pattern in the Pacific, if I just showed you that satellite image, would you be able to tell me when in the year it was located?
No, I don't think I would have a really good sense of that. I might guess that it might be autumn, early autumn,
right?
Because you'd really have a big roller in late autumn, late October or something. So I'd guess maybe early September, and that would be a terrible guess because we're not, I guess we're in the what do they call them? The bookend seasons here, or the something like that. So
right, but
that's all I would say.
But I'm thinking for September though, you wouldn't be getting the precip along the coast of the Pacific coast, right? Oregon and Washington.
That's true. That's true. It's usually offshore flow, so you wouldn't probably get that. And I don't know if you'd get this much open cellular convection. So there's another clue right there. There's pretty decently cold air that far south off the continent. That means you couldn't be in the autumn because you'd have to have produced it. You could be in the late spring because you still have pockets of cold air. So I guess if you really sat down and someone said to you, maybe refined the question and said, based upon the presence of this, what would you say? That might be a little bit of a clue about where to go. Otherwise, it would be a difficult call.
But it could be mid to late autumn too, right?
Late autumn, it could be. But by late autumn, the jets revved up and these storms would be more intense, unless you just had a really boring day. We had plenty of those last fall. So it could be late autumn, but I would qualify it as a boring late autumn day.
Right.
So, and then I would wonder why the questioner decided to show me this of all possible late autumn days in the Pacific Basin. So then I'd probably get upset.
Lindstrom shares that the ITC is wrong for autumn. So.
Oh yeah, that's another good point. Yeah, that's right.
Yeah.
That's a very good point.
That's a good point.
Okay, what was I going to do next? Oh, 500 millibar map. We already saw this, but I'll just quickly review it. Here's our feature out off the coast, which we have to worry about for the rest of the week. Here's our upper trough. Look at the flow curvature in this whole everywhere east of the Missouri River is just really highly amplified all the way out to the North Atlantic. So that's where all of the waviness is coming in, as Kalen kind of was thinking about with respect to negative NAO being associated with that kind of waviness. 300 millibars we saw also highly amplified ridge with jetlets on both sides of the thing. I mean, this is really quite an amazing wavy flow all the way out to the North Atlantic, and then fairly flat and almost zonal with the strong wind speeds across the East Coast. What I wanted to do next was, let's see, I want to make sure yeah, this is the next thing. I want to just look at the GFS. This is valid at 18Z. I'm going to go back one time so that this is kind of coincident with our analysis times. This is from Tropical Tidbits, and the thing about this is I can draw a cross-section on the fly, so I'm going to do that. We know we have this zonally oriented jet. These are 500 millibar geopotential heights colored in here in colors. And so here's our trio of disturbances that we saw on the West Coast satellite image. And then there's a trio of anticyclones underneath them because there's a jet in between. So I want to draw a cross-section through the jet and through the most intense of these three disturbances. So that's what I'm going to do right now, just to see, well, that's a bad one. I'm going to go as perpendicular to the jet as I can, and maybe I'll miss the disturbance a little bit by doing so, but I don't really care so much. So I'm trying to go right through the jet, and I'm going to look at the PV and see what that looks like in this specific jet that's going to be our next weather maker. And it's a fairly intense jet. I mean, 120, 130 knots. Here's the polar tropopause on the north side at about 350 or so millibars, and then an abrupt rise to something like 150 on the subtropical side. And then it's this is obscuring it a little bit, but it doesn't really waver much from about that height, 150 to 200 millibars. So this is an upright a tropopause wall. It's not quite the kind you see with these so-called superposed jets, polar and subtropical jets sitting on top of each other. That occurs occasionally, but it's a pretty intense tropopause undulation. And underneath it, there's a really substantial middle tropospheric, upper tropospheric baroclinic zone. The green lines are theta every 5 degrees. And notice there's almost no hint of baroclinicity at the surface. It's all contained above about 850, and it's this upper front dangling underneath the jet and dragging and in association with a bit of a tropopause fold underneath the jet as well. So this feature is going to develop more. It's not really as robust as I suspect it will be later in the weekend, but it's going to have a role to play in the weather that we see during finals week. And that's about where I am going to stop my discussion. So I'm going to relinquish control unless there's questions people have that they'd like to see something said about some of the stuff that I've displayed. Okay, doesn't sound like it. So I'm going to go back and give the control back to Michael. If I can find my page. John. Where's my page? Okay. Oh, there it is. Okay, I'm out.
All right, thanks, John, and welcome everyone. We're going to talk a little bit about the current, well, not the current weather. We're going to go into the future weather, and John talked about Cape disappointment. How about some weather disappointment? And I'm going to start with a map that he would just love if this were January or February. This is a forecast. It's a 10-day forecast. I know you don't want to go out 10 days, but can you believe it? We have snow in the forecast, at least the GFS.
Awesome.
Whether this is going to verify, and I mean that with WHETHER, is certainly, I think it's maybe a bit of a stretch. But we are going to be in a pattern which is going to be pretty chilly, which may be disappointing to a number of people. Last week we were looking at the medium range and the extended range forecast from the Climate Prediction Center. And if you recall, it had this huge bowl-shaped region over much of the central U.S. for May for temperatures where it was kind of indeterminate whether it would be above or below normal. Well, the die has been cast, and what we're seeing now is decisively for the month, it looks like, at least for the Great Lakes region, very likely to be below normal in terms of temperatures, with a good portion of the country from the high plains down to the southeast, kind of indeterminate as whether or not it's going to be above or below normal, and then the southwestern part of the United States being above normal. And we've already seen temperatures exceeding the so-called century mark in the southwestern part of the United States with a heat wave, first heat wave of the season that drove a lot of people out to the beaches, sort of breaking some of the bans they had in California or reinforcing them for social or physical distancing. But the issue is the chilly temperatures that are expected over the next month. That's kind of unfortunate. With those temperatures, or the likely below normal temperatures, maybe part of this is the balance is going to be for the first half of the month, and then maybe we'll recover after that. If you look at the 3-month period, May, June, and July, most of the country, and this is kind of typical during our, this regime that we've been in the longer term, kind of returning to likely above normal. But there's certainly a below normal, not below normal, but less likely than being above normal over the central part of the continent. So this is just a preview of maybe our upcoming mid to late spring into early summer being kind of warming up. So there's here a beep. I don't know, Pete, you could read that. Oh, that's John. Okay. If there are comments, it's hard to see it because it's obscured with the screen that I have. If you look at the temperatures forecast, not temperatures, but the precipitation in the month ahead, at least it'll be sunny but below normal. But normal for us right now is already the mid 60s, so it's not too bad, not too tough to take there. And if you look at the 3-month precipitation, looks like things begin to get a little bit wetter, perhaps slightly above normal, likelihood being above normal as we move to the May, June, and July period. If we look at shorter term, the temperatures, we'll focus on that. Again, decisive. Again, the darkest blue doesn't mean it's going to be that much colder, but it looks like certainly the likelihood of being below normal over the Great Lakes and the northeastern part of the United States is pretty strong in the 8 to 14-day period. And accompanying that in terms of precipitation, again, this looks generally dry for us and maybe wet for northern New England. And we go down to much shorter range. There's that cold air. It's very likely going to be below normal for a good chunk of the Midwest through the northeastern part of the United States and warm over the Southwest. And the precipitation during that time period, again, wet along the east and dry along much of the, surprisingly, the Gulf coastal states, as well as from the West Coast all the way through the Midwest, likely below normal precipitation during this period. So what about the shorter range? And so what we'll start with is our normal start, and we got a clarification. Thanks, I think it was Tom Whitaker that sent that to us, John.
Yeah.
Right. These are in fact meteorograms. As much as that is a mouthful to say, meteorograms is something that John would prefer. But
Yes.
we've even seen a corruption of this that gets even shorter to metgram, which we'll never use.
No.
So you can skip that. But the official term is meteorogram, and I'm glad that Genpack wins. Okay. Temperature trends. So first of all,
it's a rare victory for Genpack.
Rare victory, but Genpack will always come out on top. I hear the beeps, but I'm sorry, I can't. 63 for yesterday. What was that, John? Oh, that was Pete.
They were
Just
just
about what's the average high?
Average high.
But
Okay.
malaise on the storm temperatures from storm chasing earlier, and now just wondering what the average temperature is in Madison.
Okay. And so here's the meteorograms that show basically pretty mild temperatures are forecast. We're not going to look at the numbers explicitly. We'll look at the moss in just a short period of time. See dew points dropping off, and precip. We're looking at that line of precipitation to our west. We'll see it in the model forecast. This is the MM5 meteorogram, and it's showing no precip forecast for the next 60 hours. On our WRF page,
Nice.
we can see that. We see also the increase in temperatures here. This is in degrees Fahrenheit, approaching maybe maybe nearly 70 degrees tomorrow, which would be nice. The GFS actually has us getting all the way up to the mid 70s, 76, if you believe the GFS. Is that showing up on the screen?
Wow. Yeah, you can see that.
Right, and so that's something we're going to look at because there are a couple of factors that are going to go against this, getting this warm, but we'll see. I mean, I don't know. The current temperature outside right now is 61 degrees the last hour, so we're already running a little bit behind what the AVN Moss was forecasting for today at this time. And so we'll see. Actually, I should take that back. We'll look at it now. Nope, we're already up to 19, so 18.92, 66. We're actually running ahead of the AVN Moss by 3 degrees, so we're already 66 degrees right now. So I think the models have typically been a little bit lagging in terms of temperature, and they are today at this point. This is 18Z, I always forget that. So maybe this is not out of the question, mid-70s tomorrow, maybe even a little bit higher, but we'll see the factors that are going to be come into play. You'll also notice that the winds are out of the south, becoming southeast, but strong out of the south overnight, tonight, tomorrow morning. veering back to west and then northwest once we get to tomorrow afternoon. So there's actually going to be a frontal passage, but we still are going to manage to warm up. Let's look at the time height sections next, and then we'll look at some surface maps. So the time height sections show that brief burst of ascent, and the column beginning, the relative humidity is increasing in the mid-troposphere during the afternoon as this band of precipitation goes by. But again, we're relatively dry at the surface, very low surface dew points, so there's very little likelihood that we're going to see.
Just a little bit bigger, Michael.
Oh yeah, sure. So this is, again, time runs from left to right on this. So at 18Z, we're already in the period of the ascent beginning to pick up over us, and that's consistent with that band we saw precipitation. The relative humidity is also increasing. But by mid-afternoon today, excuse me, we're going to see strong southerly winds and that nice well-mixed layer mixing up to about a kilometer to almost a kilometer and a half in depth. And then, again, the winds become more southeasterly, but you can see a strong veering profile as that warm advection continues to intensify over us. And we mix quite well tomorrow, even to a much deeper layer tomorrow, about over a kilometer and a half or so. But you'll notice the winds actually shift from southerly to southeasterly, more to westerly by tomorrow, southwesterly tomorrow morning, and then more out of the west tomorrow afternoon. And even with that, and the relative humidity is decreased, so that's moisture plume is moving away from us. But we also see, again, the well-mixed layer gets established a little bit deeper tomorrow. And that also portends to a much warmer time period. So we get what looks to be a frontal passage when we look at the surface maps, but it's really going to be more of a wind shift. And we actually warm up. It looks like tomorrow could potentially be warmer by at least 3 or 4 degrees Celsius than we get to today. So look at the high today and then add a little bit to that. And then when we get to Sunday, it looks even warmer. So
yeah, look at that mixed layer. Wow.
Right, really deep mixed layer. Things are being, it's going to feel more like spring. And so the question is, when does the pattern change for us to begin to get chilly again with precipitation? Again, consistent with that, here's the pattern of winds in the WRF forecast. Again, southerly, and then we shift to northwesterly and westerly during the day tomorrow. Again, this is only through 48 hours, so through Sunday morning. And no precipitation either in the forecast. Now, one of the things is this is a relatively new setup. It'll get enhanced a little bit over the summer and into succeeding semesters. And again, thank Isaac for putting this together for us. Here's the 6-hour forecast. Sorry, let me get that right. This is current. There's something weird. This is an older model forecast. My apologies. Something's not quite right here. But I want to point out one aspect of this forecast. And again, this is these two blips that show up on the map over the central part of our state and the northern part of our state. These are anomalously cold regions. Now, this is near the Pentonwell Lake, Castle Rock Lake area along the Wisconsin River. And I don't know if that's just something in the topography of the model or the geography of the model and its knowledge of the lake. It's got a weird shape. You don't see this anywhere else. And if we look at even later times, these things persist. And so this is something in the land surface table or land use table that's very persistent over this time period. I'm just picking some selected times, but it's unclear what's causing that. And maybe these grow over time. So something we're going to look at and sort of pick apart, maybe a little glitch in how the land surface is modeled. But these are persistent fixed areas, which it's not clear what they are. If it's the lake in that region, but the lake doesn't have that orientation, but it's the right spot, I think, for Castle Rock Lake and Pentonwell Lake as well. Just something to look at. Kind of odd, but I'll just.
That is weird. I'm going to call that the Desai factor until we know better.
The which factor?
The Anker Desai factor. He's done something to the land surface up there that's made the model go crazy.
Could very well be the case. So here's the surface reflectivity. This is 6 hours. This is the WRF forecast. I believe this is 18Z, so this map is current. It's up to date. You can see the model forecasting by this time period for light precipitation to spread over our area. Again, the trace from the meteorogram for accumulated precipitation was close to 0. So this is all evaporating before it reaches the ground. This is actually a reflectivity image. This is not an actual radar summit. This is what the radar should look like at this fairly coarse resolution. with light precipitation over us by this time. And it looks, the back edge of this looks very much like what we saw on the radar that John showed earlier. And here's some comments. Oh,
just a quick mention. That's Louis Uccellini is on for part of the discussion today. He just said hi, and thanks
hi,
for
Louis.
The Weather Watch.
That's great, Louis. Thanks for coming by.
Yeah, thanks for joining us. I'll just say hope to see you soon at some point. And then we see the precipitation continues to move off to the east. And again, in the model forecast, but none reaching the ground. So this band of precipitation is forecast by the model. This is the reflectivity. And that's kind of an interesting thing. You compare the reflectivity with accumulated precip. And that's not accumulated precip. With accumulated precipitation at 3 hours. And see, the model does a really great job. It has what the reflectivity would look like, but you actually see no accumulated precip. So that's really nice.
That's awesome. Isn't that awesome? I mean, think about the sophistication that testifies to. That's remarkable.
Right. So this is really great to see something like this. And I don't think if we look at the, I should compare it with the MM5, but again, this is really a nice modeling system that's set up. And we're going to begin enhancing this with actual observations being entrained into this and not just cold starting this off of the NAM forecast. And that's a longer term project. But you can see 12 hours of the forecast, the winds are going to shift the geostrophic winds out of the southwest. So it's going to be nice warm advection. Elsewhere across the continent with that deep upper trough to our east by this evening, still showery precipitation under it. It's unstable, but you have also this Ekman precipitation as well, and a few showers expected over the Rocky Mountains during this time period. But a nice cyclone beginning to set up in the northern plains, or just north of Minnesota. I'm going to jump ahead just because of interest in time to tomorrow morning. This is the 500 millibar flow, strong westerly flow that's developed over us, and that pretends to flow over the Rockies. It should be dragging to the east. A nice warm sun. We'll see that in the thicknesses in just a moment. But also, this is looking at the ice attacks at 500 millibars at this point. It's a little jet maxima at 500 approaching us at this point. In terms of heights and vorticity, flow is, again, strong westerly flow, little bits of shear vorticity that are embedded in this, but no really well-organized disturbance at this point. The upper trough by tomorrow is moved offshore, and we're in this westerly flow. We go to the surface tomorrow morning. Get this right. And there's that nice thermal ridge you can see in the thickness, these yellow contours, nice thermal ridge axis that exists over us. And so a little bit of light precip just to our northeast and east of us tomorrow morning. It's forecast by this particular model. And precipitation back across northern, again, along I-80 from just north of I-80 when you go into Nebraska and into Wyoming. But relatively dry. Yeah, question? Pete, if you could read that. It's hard to... Oh, John.
Yeah, Michael, I forgot to show in my overview of the Wednesday and Thursday storm that the evolution looked very similar to what you're showing here for the one that's coming in. There was a substantial lee side component that was down over the southern plain states, and then the upper wave was relegated at some point to the middle part of that latitude band, and the cyclone began to develop. I think you could see it on the reflectivity that Pete saved. Cyclone began to develop in the northern plain states, and then finally, as they got themselves amalgamated east of the Mississippi, it was one storm as it kind of put itself together over parts of Illinois and Indiana, and it's looking the same thing with this new development, slightly displaced a little to the north compared to that one. So
oh, that's really neat. That's really neat seeing that development and the lee side development. So here's actually a loop of that 500 millibar forecast. This is through 48 hours, every 3 hours, and you can see the this trough beginning to organize over Ontario at the time period. But here's the exiting trough that you talked about nicely earlier in the weather discussion. Here's this westerly flow.
yeah, it's nice. That's a really nice animation.
Yeah. So you can see that, and the heights begin to fall near the end of the period over us. At the surface, just to quickly do this loop, again, here's the warm advection that sets up for the day tomorrow. Winds shift to northwest by tomorrow morning, but we stay dry, and there may be a little bit of precip to our south along this developing frontal zone as that moves to the east. But a dry weekend for us, a really warm day setting up tomorrow and again on Sunday, even though we do have what appears to be a robust cold advection. It doesn't get super cold over us during this time period. So what I want to do next is go back to Pivotal, look at the GFS over the same time period very briefly, and then take a look at the forecast for the longer range and see how we begin to turn cold. So this is tomorrow morning. Again, it sets us up. You can see nicely where that front is going to be. It is definitely a cold front. You can see the trough that shows up very nicely from just northwest of Green Bay, just to our north into southeastern Iowa. If you look at the temperatures at this time, it'll be temperatures and wind, so you can get that up. You don't really see much of a, you can see a kink in the isotherms, you can see the wind shift, but the really cold air is really far back to the northwest. So John, I don't know if you would classify this as just a wind shift, or would you even call that a cold front?
I think it's a lee side trough. It's got a warm axis right where the vorticity maxima is. I think that's probably a lee side trough. And then gradually, as the cold advection swings around from the northwest, from behind that Arctic front, it'll fill that trough in. It'll look more like a cold front by the time it's further east, but right now it looks like a lee trough to me.
Yeah, I think you're right about that. I mean, this is clearly, you can see the axis of the warmest temperatures is in fact nearly coincident with the wind shift. So that's definitely a trough. If you had to put a front associated with this weather system, we'd be all the way back up in Canada, perhaps.
I would, yeah, that's what I would do. And I draw a dashed line through this trough across Wisconsin. That's exactly what I would do. Yep.
Yeah. So tomorrow afternoon, so no cold frontal passage. It actually is just a wind shift. By tomorrow evening, you can see that the temperatures have cooled off here. You see this really curious feature that extends from Nebraska all the way across central Iowa. Again, this is right along I-80, and this is a band of precipitation that's cooling this area off. Clouds and precipitation north and south of it. It's warmer. You can look at the precipitation rate map that we have right here, and in this case, it looks like there's a little bit of light precipitation here, but it's really just clouds right along this. You can also see hydrostatically where it's cooler. There's actually a little nice ridge that extends along the same region.
It's a fairly intense southeasterly low-level wind speed too, isn't it, in northeastern Colorado where the precipitation maximum is? Maybe that's upslope.
Yeah, I think that is. We'll look at a, put some winds on there in a second. Here's the accumulated precipitation. You can see that shows up nicely there too. So even though there's continuously a little precip, clearly going to be clouds here and there's going to be precipitation. If you look at the winds, again, the 10-meter winds over Colorado, there's that southeast wind. Again, over this huge expanse, as you go across Nebraska and Kansas, elevations are increasing. And so any easterly component of the wind is really ascending. So you have it right along this region. But a really thin ridge axis that shows up nicely. You can see the wind shift from easterly just near I-80 to north of I-80, it's more westerly. So it's going to be a really thin ridge that sets up here. And again, the cold advection is really way back to the northwest. There's more warm air to come for us over the weekend. By Saturday morning, or Sunday morning, excuse me, we're in this still northerly flow. There is weak cold advection that's starting up over us, but it looks, again, to be a fairly dry day. I'm just going to quickly go to 60 hours in the forecast. Oops. Okay, it stays dry. Temperatures on Saturday, by the time we get to the evening, have cooled off a little bit. They're back in, forecast to be only in the middle to upper 50s by that time. And I suspect this is maybe just a little bit warmer than this, at least based on some of the other maps that we had looked at. And as we go ahead to Monday, I'll stick with precip. What's going on? This has frozen. Can you guys hear me?
Yeah, I can hear you.
Okay, something's not.
Wonder if somehow the screen sharing got messed up.
No, I can't even. I'm clicking on things and it's not advancing. So what I'll do is just try to go to a different. I don't know if it's my internet. Well, you can hear me, so it's not the internet. I wanted to get to this final time period because the forecast basically has for us to get colder over time as we get into that 6 to 10 day period. And maybe, Pete, if you can bring that up, I'll stop sharing. Oh, did the screen sharing stop? I see it, that it did.
Yeah, the screen sharing stopped. Do you want to try and share it again?
Yeah, I'm trying right now, and I'm not bringing it up. I just want to look at the surface precipitation rate maps. If you could bring that up, I'm just going to It stopped again. I don't know what's going on. It says I'm reconnecting.
You're still connected as far as I can tell, but I'm about to share my screen, so I'll
Yeah.
go to.
Okay, please do. I just want to just step us through to in steps of about a day, starting on Wednesday, and just go forward.
So let's see. Are you seeing my screen?
Yeah, I see it. I see it.
You want the local for Midwest?
No, let's just keep this so we can see the full picture of the continent. And let's start at 96 hours, please.
Just like in room 811.
Yeah.
So this is 96 hours.
That's 96. So this is Tuesday morning, and we have the next weather system. And it's this parade of weather systems that are moving across the country. We're getting to warm advection. You can see this looks more akin to sort of spring with the warm advection. You see the precipitation showers lining up along the developing cold front with this cyclone that's centered over western Minnesota. So that's a pretty decent cyclone, John, at 998.
Yeah, that's beautiful, isn't it? That's a really nice little system.
Right, and just to the east, just western Lake Superior, even a little bit of snow too, just on the leading edge of this, early in the morning on Tuesday. You can
That's
see that.
just for Croy. That's for Croy.
Yeah, of course,
He's
and
moved up to Duluth.
we got 120 hours. It's going a day out. The cyclone will pass, and we're back into cold advection. Thickness is dropping below 540, and sort of a showery period with clouds. Again, that Ekman ascent we're expecting. And then Alex is saying pretty impressive severe weather setup, maybe in the southeast. But you can see the complexion of the patterns change with the cyclone now just at about our latitude and the cold advection beginning to commence. We'll go ahead to 144 hours. Please, Pete. It's just like, now I get what you mean by, it's like we're in room 811. And so cold advection and just dry but chilly time, and this can be a chilly period for us. We can look at the surface temperatures that morning. So this is Thursday morning. The 2-meter temperature, please, Pete. Oops, things are getting slow, I think, or maybe it's me.
I think it's you, Michael.
Okay, I'm just slow. Look at that.
Got it?
Yeah, so that's only, what, 30 degree,
Yeah, miserable.
Upper 30s on Wednesday morning. So I
It
put
looks
some
to be
plants outside.
worse.
Could be worse. It will get worse. We'll see.
It looks like it'll get worse. Yeah.
Yeah. And we go back to the precip maps. We'll go to next Friday. Precip rate. Type in
Did you
rate
guys
map.
see that tweet from Nick Basil that I posted in the comments earlier?
No, I didn't.
Real quick, this is it.
Oh yeah.
Oh yeah, brutal.
So this is really a cold period coming up. This is it's an ECWF ensemble as well. Anywhere from 7 to 10 degrees Celsius colder than normal over the Great Lakes and Northeast. So here's 168 hours. This is a week from today. This looks, this could very well be late fall.
Yep. This is when I'm giving my final. So boy, oh boy. What a
Well,
slap in the face.
There.
Right. That's just amazing. And then at 192, and this is not just, we're looking at one forecast run, but I've looked at a couple that led up to this. Look at this, 510 thickness. What?
510. That's unbelievable. That is unbelievable.
And if you look at this, Alex is polar vortex, but one of the interesting things about this is just having a single event like this can set the whole complexion for the month in terms of the climatology for the month.
Oh yeah, that's right.
This will leave a mark.
Yeah, that's right. This will be a black eye on the month of May, no matter what happens next.
Jeez, 510 thicknesses. So you can see the evolution, and just for to be honest about the forecast, there's snow all the way down to southwestern Ohio. That's just incredible.
Yeah, that's amazing.
Again, if this were to verify, but we can look at the let's look at a couple other runs, model runs. If we go back to the
lake effect snow in Chicago.
Yeah, let's hope this is an effect of the missing plane observations and the forecast degrading.
Yeah, so if you look at the 0-hour forecast, oops.
What do you want to see?
Not ECWF. Let's keep with this, the GFS. We learned a
0
lot
hour?
about the zero. So the zero, so not 0 hour, but the 0Z, the one from 0Z today.
Oh, different run.
Again, this is just looking at sort of a lagged average forecast. What were other runs suggesting? Something very similar, but not as cold.
Mm.
You can see that. You can see that really impressive trough that's to the west of that cyclone in Quebec, with a precip there. And this is is this the run from yesterday?
Previous 12Z run, yeah.
So it's the 12Z yesterday, which had more of a much milder pattern, significantly milder. And if we go back and look at the ECWF as it's coming in, I don't know how far out it is. Maybe look at the 0Z ECWF first. Sorry, Pete. And we don't want to rely on just one model. We'll look at that.
I do if it's cold.
You seriously would want snow?
Yeah.
So what time was that? 100 and...
That was over a week out, so let's say 192. That looks cold. Let's look at this, just the 2 meter temperature, or 2 meter temperatures. You can see that had a little bit of snow with it and colder temperatures. That's chilly at 0Z with temperatures only low 40s. So there is really going to be a change in our pattern. We're going to warm up, over the weekend into early next week, and then a decisive change. And unfortunately, we didn't have time to really go into the details of what leads to this, but it'll be a really interesting, at least hopefully temporary pattern change to much colder than normal. But we've already been in a below normal regime most of April, I think. I haven't looked at the final climate for the month, but it's been.
Oh, we've got that. Here's the thing from Ed. He updated it as of today.
Yeah, so I guess it's pretty fair to say we've been below normal for much of April. Can you scroll it up just a little bit, Pete, to see the date? Yeah, there we go. Yeah, so most of this month has been below normal, well below normal earlier, and so it's not really a repeat. It's a brief anomaly that we're gonna warm up this weekend. Maybe 10 degrees or so above normal, and then drop back down to well below again. So our summer starts off, for the end of semester, mid spring period is going to start off well below normal, and then hopefully it'll recover during the summer. But a cool summer would not be bad at all, as long as it's just cooler than normal, not colder than normal.
Yeah.
So that's it for the somewhat abbreviated weather discussion on my part. Thank you, John, for a wonderful discussion, not only today, and also Pete contributing, and Greg, I don't think he's on today, but thank you guys for just making this a fun experience and enjoyable. And it's about the seriousness of looking at the atmosphere and understanding how it works, and the communication of that in a really effective way. And we have the tools to do it, thanks to Pete and leaders to do these discussions like John and Greg and many others, and some of the students and graduates that have participated this semester on this. I really, really appreciate all of that, and just the getting together and talking about the weather has been fun, and I think reinvigorating this.
Continue doing this on Fridays. I know Michael and John want a break from running the discussion every week. So if anybody else, students, alumni, anybody, if you're interested in hosting or just getting together and talking, shoot me an email, poker@aos.wisc.edu, and like I said, I'm happy to gather here, and if somebody wants to take the lead, we can, or we can just talk or whatever. So.
Yeah, thanks. Also, I think we already have a volunteer, Chris Malcolm, that signed up for sometime later on. I think that's correct.
Yeah, once the June season starts up.
Right. So,
yeah, I echo all of Michael's comments. I very much appreciate everybody coming along and doing this. It's when you're interested in weather science, you have to take a clinical approach. You have to acquaint yourself with the weather every day to stay on top of it. And Pete, thanks for organizing it. Michael, for great discussions every time, and for all the feedback from everybody. It's great.
Yeah, this has been fun, and we hope you all just stay safe, stay well, and hopefully we'll meet face to face in not too distant future.
Yeah, that's what I'm hoping too.
All right. Thanks, you guys.
All right. Thank you.
Thank you.